We have never seen the top of the sun. Not once. Not in all of human history until last year. Think for a second about how strange that is. We have landed machines on Mars. We have flown past Pluto, 3 billion miles away, close enough to count the mountains on its surface. We have a probe that has physically left the solar system and kept going. And yet the poles of our own star, the single object that every heartbeat on this planet depends on, stayed hidden from us until the spring of 2025. I know how the title of this video sounds. That is exactly the kind of claim that should make you raise an eyebrow. And honestly, you should. So let me tell you up front what this is and what it isn't. The first real images of the sun's pole are not a guess. The European Space Agency captured them in March of 2025 and put them in front of the world. The discovery that our entire solar system is sitting inside a hole blown open by exploding stars is not something a YouTuber invented. It is a 2022 paper in the journal Nature, built on the most detailed three-dimensional map of our corner of the galaxy ever assembled. Nothing here tonight is speculation or wishful thinking. Every piece of it was measured, photographed, or published in a journal. And here is what those measurements quietly add up to. For all of human history, we have been facing the wrong way. We have stared outward, sideways, across a flat little disk of planets, straining to hear a voice in the silence. The real story was never out there in the dark between the stars. It was up and it was down, in the one direction we almost never go. When we finally turned and looked that way, three things were waiting for us. The top of our own star, and it was far stranger than the face we thought we knew. A wall of long, dead stars, wrapped around everything we have ever called home. And a wind. A steady wind that has been blowing through this solar system the entire time we have existed. And not one of us ever felt it. By the end of this, the emptiness above your head is going to look completely different. But to understand what is up there, you first have to understand why, for 4.5 billion years, almost nothing has ever managed to get there. Because there is a reason we have always been stuck looking sideways. And it is built into the shape of the solar system itself. There is a reason, and it starts 4.5 billion years ago with a cloud. Before there was a sun, before there was an Earth, there was an enormous cloud of gas and dust, drifting in the dark and slowly turning. Every cloud like that has a little bit of spin, just by chance. And as gravity began to pull it inward, something took over that you have actually seen with your own eyes. Picture a figure skater spinning with her arms stretched out wide. When she pulls her arms in tight, she does not slow down. She whips around faster, almost instantly. That is a law of physics called conservation of angular momentum, and the universe enforces it without exception. You cannot simply get rid of spin. So as our cloud collapsed inward under its own gravity, it spun faster, and faster, and faster. And a fast, spinning cloud cannot fall into a neat little ball. The spin throws material outward around the middle, flattening the entire thing into a disk. A vast, turning plate of gas and dust, with a brand new sun igniting at the center. And here is the part that always stops me. We do not have to guess that this happened. We can watch it happening right now, around other stars. When astronomers point the giant ALMA telescope array in the Chilean desert at a young star like HL Tauri, they see exactly this: a newborn sun wrapped in a flat, glowing disk with dark gaps already carved into it, where new planets are sweeping up material. We are looking at photographs of other solar systems in the act of being born, and every single one of them is flat. Our own flatness is not a quirk or an accident. It is a law written into the way stars and planets come into existence anywhere in the universe. Every planet in our system formed inside that plate. Every moon, every asteroid, every comet you have ever heard a name for, all of it condensed out of that flat spinning disk. And that is why, even now, billions of years later, they still travel around the Sun in almost exactly the same plane. Astronomers call it the ecliptic. The solar system is not a buzzing swarm of objects going every direction. It is closer to a record on a turntable. If you shrank the whole thing down to the size of a dinner plate, it would be thinner than the paper this sentence could be printed on. Now here is the trap. We did not just form in that flat plane. We are still locked inside it, and we are moving through it at a staggering speed. Right now, the Earth is carrying you around the Sun at about 30 kilometers every single second, faster than any bullet ever fired. And every bit of that motion is aimed sideways along the disk. None of it, not 1 kilometer per second of it, is aimed up. So imagine you wanted to escape. You wanted to fly straight up out of the plane and look down on the whole solar system from above, the way you would look down on that spinning record from the ceiling. To do it, you would first have to cancel almost all of your enormous sideways speed, and then build up a brand new speed in a direction where nothing, absolutely nothing, is already moving. To an engineer, that costs a fortune in what they call delta V, the total change in motion a spacecraft can afford over its whole life. Reaching Mars is cheap by comparison. Tilting your path up and over the Sun's poles can cost more energy than flying clean out of the solar system. Going up is the single most expensive ticket in space. It is so expensive that even our boldest Sun mission, the Parker Solar Probe, the fastest object human beings have ever built, stays loyal to the plane. It dives in toward the Sun. It does not climb over it. Because falling inward is something gravity will happily do for you, for free. Rising up and out is something gravity fights you on every single meter of the way. This is the prison we live in. Not a prison of walls or bars, but a prison of velocity. Everything we know is sliding along the same flat track at incredible speed, which makes straight up feel like a door that has been welded shut. So every probe we have ever built quietly took the cheap road and hugged the plane, because that is the only place the math will let you go without an impossible amount of fuel. And for decades, that welded door left us with something humbling, almost embarrassing. We could fling spacecraft to every planet in the sky. We could map the frozen edge of the solar system. But the poles of our own Sun, straight up from where we stand, stayed completely beyond our reach. To get a single look at them, somebody was going to have to pick the lock. Somebody was going to have to break the oldest rule in the solar system on purpose. And in the 1990s, one strange little mission set out to do exactly that. The mission was called Ulysses, and its plan sounded almost insane. If you want to fly up and over the Sun's poles, you have to break out of that flat plane we just talked about. And we established that doing it with raw rocket power is very nearly impossible. There is not a rocket on Earth big enough to simply muscle a spacecraft straight up out of the ecliptic. So the engineers behind Ulysses, a joint project between the European Space Agency and NASA, did something clever, something that still feels a little like cheating. They decided to borrow the gravity of the biggest planet we have. Here was the trick. Instead of aiming at the Sun, Ulysses launched in 1990 from the cargo bay of the Space Shuttle Discovery and headed in the opposite direction, outward, all the way to Jupiter. That sounds completely backward, and it was supposed to. Because when Ulysses arrived at Jupiter in 1992, it dove past the giant planet and let Jupiter's immense gravity grab it and fling it like a slingshot. But not forward and not sideways. The flyby was angled to hurl the little probe down and clean out of the plane, kicking it onto a brand new path that looped up and over the sun from top to bottom. There is a detail here that tells you just how strange the geometry of up really is. Ulysses could not run on solar panels. Swinging so far from the sun and over its poles, sunlight would be too weak and unreliable to trust. So it carried a nuclear battery, a generator running on the heat of slowly decaying plutonium, the same kind of power source we send to the outer planets where the sun is just another star. To study the sun up close, we had to build a spacecraft that did not depend on the sun at all. And it worked. Ulysses became the first spacecraft in history to fly over the poles of the sun. It soared high above the solar South Pole, then swung all the way around and crossed the north. And then it did it again. And again, looping the sun from top to bottom for more than 18 years, far longer than anyone had dared to promise. For the first time, a machine from Earth was studying our star from above and below instead of from the side like everyone always had. And what it found was genuinely new. Down here in the plain where we live, the solar wind is slow and gusty and bad-tempered. But over the poles, Ulysses flew through a completely different beast. A fast, smooth wind pouring off the sun at around 750 kilometers per second, nearly double the speed. The sun was breathing differently from its crown than from its waist, and we had never known because we had never been able to stand anywhere but at its equator. Over its long life, Ulysses looped the sun's poles 3 separate times, catching our star in completely different moods, once in the quiet of solar minimum and once in the storms of maximum. It even blundered through the tail of a passing comet and recorded the sun tearing away pieces of its own outer atmosphere. Every orbit rewrote another page of a textbook we had assumed was already finished. But there is a catch, and it is the whole reason this story did not end in the 1990s. Ulysses was blind. It carried instruments to taste the solar wind and feel the magnetic field, but it had no camera pointed at the sun. It could measure the space around the poles, but it could not take their picture. It was like sailing all the way to an undiscovered island in total darkness, reaching out and touching the shore with your hands, learning the shape of every rock and inlet by feel, and then sailing home without ever once seeing it in daylight. So even after Ulysses, even after that brilliant, lock-picking trajectory and 18 years of patient work, we still had no actual image of the top of the sun. We knew it was there. We had felt our way all around it. But no human eye and no human camera had ever truly seen it. If you are still with me at this point, you already understand something most people never stop to think about. That the most familiar object in our entire sky, the sun we have drawn as a simple yellow circle since we were children, had a face we had never once looked at directly. Quick favor, if a channel like this is the kind of thing you want more of, the subscribe button genuinely helps these get made. No pressure, let's keep going. Because that missing picture, the one Ulysses could not take, sat empty for almost 30 more years. And then last year, a second spacecraft finally finished the job. And when the first images came back, the top of the sun did not look calm, or simple, or anything like the smooth yellow disk we had always expected. It looked like chaos. The spacecraft is called Solar Orbiter, and it is, once again, a joint mission between the European Space Agency and NASA. And it solved the puzzle the same way Ulysses did, by stealing momentum from gravity, but with a twist that took years of patience. Solar Orbiter did not just slingshot once. It has spent years flying loop after loop through the inner solar system. And each time it swings past Venus, it borrows a little of the planet's orbital motion in a maneuver called a gravity assist. Venus tilts the spacecraft's path again and again, like a patient hand giving the same gentle push on every pass. With each lap, the orbit leans a few more degrees out of the flat plane. Slowly, methodically, Solar Orbiter has been climbing the staircase out of the prison of velocity, not by brute force, but by negotiating with Venus over and over. And it is not finished. With more Venus flybys still to come, the orbit will keep tilting, until by the end of this decade it will look down on the Sun from more than 30 degrees up, higher than anything has ever managed before. But it had already climbed high enough. In March of 2025, from about 15 to 17 degrees below the solar equator, Solar Orbiter turned its instruments toward the bottom of the Sun and took the shot. For the first time in the entire history of our species, we were looking straight at one of the Sun's poles. Not feeling for it in the dark like Ulysses, seeing it. And it was not one camera, but three working together. An instrument called the Polarimetric and Helioseismic Imager mapped the magnetic field line by line. The Extreme Ultraviolet Imager photographed the million-degree atmosphere boiling above the surface. And a third called SPICE traced individual elements, carbon, oxygen, neon, as they rose off the pole, letting us read the temperature and motion of the gas itself. Three different ways of seeing, all aimed at the one place we had never once looked. And I have to be honest with you about my own reaction to what came back, because it caught me off guard. I had always pictured the poles of the Sun as the quiet ends of a magnet. On Earth, the magnetic field is tidy. North Pole here, South Pole there. One clean arrow running through the planet, the kind of thing a compass needle can trust with its life. I assumed the Sun would just be a bigger version of the same thing. It is not. Solar Orbiter's magnetic instrument looked at the South Pole and found a mess. Both magnetic polarities, north and south, jumbled together in the very same place at the very same time. Now, that sounds like a malfunction, but it is actually one of the most important things we could possibly have found. The Sun is near the peak of its 11-year cycle, a phase called solar maximum, when its entire magnetic field flips upside down. North becomes south, and south becomes north, and we caught it in the act. The chaos at the pole is the Sun in the middle of turning its whole magnetic self inside out. We had theories about how that great flip works for decades, but we were always guessing from the side, like trying to understand a whirlpool by studying only its outer edge. Now, for the first time, we are watching it happen from above, and the complete pole-to-pole dataset is still streaming home to be unpacked. And this is not just a beautiful picture for a textbook. That magnetic flip is what drives the solar storms that can knock out power grids, scramble satellites, and endanger astronauts. Learning to read the poles is how we will one day learn to predict the Sun's temper before it turns on us. So think about what that means. We have spent centuries studying the Sun, building our entire understanding of it, and we were doing it the way you would try to understand a person by only ever seeing them from the shoulders down. The most dynamic, most important real estate on our star, the place where its magnetic engine resets itself, was a blank spot on our map until last year. But, and this is where the whole story cracks open, the pole of the Sun was only the first reveal. It is the closest thing in the sky we had never seen from above. The answer to the question hanging right over our heads. And the moment we pulled our gaze up off the sun and kept going, kept looking up and out, past the planets, past the comets, past the very edge of everything the sun controls, we ran straight into a discovery that makes a chaotic magnetic pole look almost cozy. Because it turns out the entire solar system, the sun and all of us along with it, is sitting inside something enormous. And until very recently, we did not even know it was there. To find it, you have to stop thinking about the solar system and zoom out, way out. Forget the planets for a moment. Picture our entire solar system all the way out to the most distant comets as a single dot. Now pull back until that dot is lost in a sea of nearby stars. This is our neighborhood, a patch of the Milky Way a few hundred light years across. And for a long time, we assumed it was fairly ordinary. Just stars scattered through the usual thin gas that drifts between them. Then we built better maps. In 2022, a team of astronomers led by Catherine Zucker using data from the European spacecraft Gaia published something remarkable in the journal Nature. Gaia had measured precise distances to more than 1 billion stars, and from that, the team built the most accurate three-dimensional model of the gas and young stars around us ever made. Not a flat picture pinned to the sky, but a true map you could fly through. And when they assembled it, a shape jumped out that nobody could ignore. We are sitting inside a bubble, a vast, nearly empty cavity in space about 1,000 light years across. The gas inside it had been thinned out to almost nothing, hot and sparse, and it is wrapped in a shell of cold, dense gas and dust on the outside, like the skin of a soap bubble. Astronomers call it the local bubble, and our sun is currently drifting through the middle of it. So where does 1,000 light-year hole in space come from? The answer is violence. Long before humans existed, this region was thick with gas, and out of that gas, a cluster of massive stars was born. Massive stars live fast and die hard. Starting around 14 million years ago, those stars began detonating as supernovae, one after another, at least 15 of them. Each explosion slammed a shockwave into the surrounding gas and shoved it outward. Blast after blast, over millions of years, those dying stars swept the region clean and carved out the enormous cavity we live in today. And here is where this stops being a story about distant space and becomes a story about the ground beneath your feet. Because we are not only inferring those supernovae from a map, we have their ashes, buried in the floor of the deep ocean, in slowly growing crusts of iron and manganese that build up in layers like the rings of a tree. Scientists led by Anton Wallner found an isotope called iron-60. Iron-60 is not made on Earth by any natural process. It is forged in supernovae, and it is radioactive with a half-life of about 2.6 million years, which means any of it present when the Earth formed decayed away billions of years ago. So every atom of it we find had to have arrived recently from space. And we find it in samples from the Atlantic, the Pacific, and the Indian Ocean, all across the planet, laid down most heavily around 2.5 million years ago, with a second pulse around 1.5 million. The very same radioactive dust has now been pulled from the soil of the moon as well. Sit with what that means. The supernovae were close, around 300 light-years away, and their debris drifted across space for thousands of years, then sifted down through our atmosphere and settled onto the seabed. As our earliest ancestors were learning to walk in Africa, the sky was quietly seeding the oceans with the ash of dead stars. We are not reading about those explosions in a book. We are standing on their fallout, and our sun, we are just passing through. It did not form in this bubble. On its long orbit around the galaxy, it wandered into this cleared-out cavity only about 5 million years ago, long after the explosions that made it. We are tourists, drifting through the blast site of an ancient catastrophe. There is an even stranger detail in that map. Nearly every young star forming near us today sits right on the surface of this bubble, on that dense outer shell. The same shock waves that emptied the inside piled the gas up on the edges, and in that piled gas, brand new stars are being born right now. The explosions that could have sterilized this region are also a cosmic nursery. Death on the inside, birth on the skin. So for a moment, the mystery feels solved. What is above and below the solar system? Apparently this, the empty inside of an old, enormous bubble, blown clear by stars whose ash is sitting in our oceans, with new stars glowing on its distant walls. Vast, ancient, and basically hollow. A finished story. Except it is not finished. Because empty turns out to be a lie. That bubble we are drifting through is not still, and it is not silent. There is something moving inside it, moving right through the solar system as you breathe, and once you know it is there, the idea of empty space never feels the same again. To feel it, come back in from that 1,000 light-year bubble to our own sun, and look at the much smaller bubble it blows around itself. The sun is constantly streaming out a wind of charged particles in every direction. We call it the solar wind, and it inflates a protective bubble around the entire solar system called the heliosphere. This is the sun's own territory, the region where its wind pushes back against everything outside. All the planets, all of us, live deep inside it. It is part of the reason life on Earth is possible at all, deflecting much of the deadly radiation that fills the space between the stars. And for a long time we drew it as a simple shape, like a comet. A round head facing forward and a long, graceful tail streaming out behind. But in 2020, a team led by the physicist Merav Ofer ran the numbers in a new way, and the comfortable comet shape fell apart. Their model suggests the heliosphere is not a tidy teardrop at all. It is lopsided and squashed with two strange lobes curling off it. They described it memorably as a deflated croissant. Our home bubble is a dented, asymmetric thing, and the reason it is dented is the key to this whole story. It is being shaped by a pressure from outside. Something out there is pushing on it, and here is the something. Our solar system is not sitting still inside that giant local bubble. It is ploughing through it. We are moving through a specific patch of gas called the local interstellar cloud, sometimes nicknamed the local fluff, at around 26 kilometers every second. And when you move that fast through any gas, even gas this thin, you feel it as a wind. There is quite literally an interstellar wind blowing against the solar system right now, not as a metaphor. A real, measurable headwind of atoms streaming in from one fixed direction in the sky. And we are not guessing about that wind. We built a spacecraft specifically to feel it. In 2008, NASA launched a small mission called IBEX, the Interstellar Boundary Explorer, to map the very edge of the heliosphere from the inside. It catches neutral atoms, particles that drift in from interstellar space carrying no charge, and uses them to picture a boundary we can never photograph directly. And in 2009, IBEX found something nobody had predicted. A long, bright arc across the sky, a feature we now call the ibex ribbon, tracing the line where the galaxy's own magnetic field drapes over our bubble. We had captured, in a sense, the seam between our solar system and the rest of the galaxy. I want you to sit with that because it genuinely stops me cold. There is a wind from between the stars, and it is hitting us at this exact moment. You cannot feel it because our sun's bubble, that deflated croissant, is taking the hit for us. The place where the solar wind finally loses and the interstellar wind wins is a boundary called the heliopause, about 120 times farther from the sun than the Earth is. It is, in a real sense, the true shoreline of the solar system, and only 2 human objects have ever crossed it. Voyager 1 in 2012 and Voyager 2 in 2018, both of them passing out of our bubble and into raw interstellar space, where their instruments felt the gas suddenly grow denser and colder, the first direct touch of the world outside. So when we ask what is above and below us, this is the deeper answer. It is not empty. We are a small bubble inside a much bigger bubble, and the space between is full of moving gas, pressing on our boundary and reshaping it as we speak. And it gets more alive than that. When scientists compared the direction of the interstellar wind measured today against the very first measurements from the 1970s, they found it had moved. The wind now blows in from an angle nearly 7 degrees different than it was 40 years ago. What presses on us is not a steady, eternal breeze. It is changing within a single human lifetime. And we're not even safely in the middle of our little cloud. We are near its edge, sitting right where the local interstellar cloud meets at least one neighbor, a separate cloud astronomers call the G cloud, with possibly several others crowded up against it. We are at a border crossing between regions of interstellar weather, and within a few thousand years, the sun is expected to push out of this cloud entirely and into the next, which means the wind we feel is going to change again. The thing pressing against us is not constant, and it is not finished with us. Something out there is in direct contact with the solar system, touching its very edge and slowly, quietly shifting. So we started by asking a simple question: what is straight up from here? And the answer has quietly turned into something else entirely. Let me pull all of it together now, because this is where the whole picture finally clicks into place, and it answers the question I planted at the very beginning. I asked when we finally turned and looked up, out of the plane we'd been trapped in for all of history, what was waiting there? Here is the full answer. Start at your feet and travel outward. You are standing on a planet locked into a flat disk, a fossil of the spinning cloud that made us, moving sideways so fast that up was a sealed door for almost our entire existence. Pick the lock, climb out of the plane the way Solar Orbiter did, and the first thing you find is the top of your own star, caught in the middle of flipping its magnetic field inside out. Keep going up. Push past the planets, past the comets, past the deflated croissant of our own bubble, across the heliopause where Voyager felt the gas turn cold, and you reach the bright seam of the ibex ribbon, the line where the galaxy's magnetism wraps around our home. Keep going further still, and you realize all of it, the wind, the ribbon, the boundary, sits inside an enormous cavity 1,000 light-years wide, hollowed out by at least 15 stars that exploded long before we ever arrived. Now look at how those pieces connect, because this is the part that genuinely changes things. The supernova that blew our bubble did not just leave a hole. Their shockwaves piled gas onto the bubble's walls, and on those walls, new stars are being born right now. The same explosions that cleared our neighborhood are seeding the next generation of suns around us. And the gas from that ancient violence is the very wind we are drifting through today. The wind ibex watches shift direction from one decade to the next. This is not a chain of separate, unrelated facts. It is one connected, living system, and we are sitting inside it. And every layer of it was hidden from us by the same simple accident. We were born sideways, pinned to a spinning disc, able to see only along the plane, the one direction our speed would ever let us look. The flatness that trapped us also blinded us. It took a nuclear-powered probe slung off Jupiter, a spacecraft bargaining with Venus for years, telescopes pinning down 1 billion stars, and grains of radioactive iron from the floor of the sea, just to let us turn our heads and notice the room we've been standing in this whole time. The discovery was never really out there in the dark. It was in being able, at last, to look up. And the strangest part is how recent all of it is. The poles, the bubble, the ribbon, the shifting wind, every piece landed within living memory. The people who raised us were taught the space above our heads was empty. They were wrong, and we are the first humans who get to know it. And remember the ashes. The iron 60 in the deep ocean floor is not a metaphor, and it is not a maybe. It is the actual debris of those dying stars, atoms forged in the heart of a supernova, carried 300 light years across space and settling into the rock of our own planet while our ancestors watched the same sky. The story playing out above your head is also buried beneath your feet. We are not observers sitting safely in a void, peering out at a dead and distant cosmos. We are inside it. We are a small, moving piece of a living, breathing structure, exhaled by dying stars and inhaled by newborn ones, dusted with their ash, with the wind of the dead blowing through our solar system at this exact second. That is what was looking back. Not eyes. Not a creature. Something stranger and far more humbling. For all of history, we faced outward and listened to the silence between the stars, and we decided the universe was empty and that we were alone in it, and that the space above our heads was nothing at all. We were wrong about the most basic fact of where we live. The void above us is not a void. It is crowded with the wreckage and the offspring of stars. It is moving, it is changing direction within our lifetimes, and it is in direct physical contact with us. Right now, pressing on the edge of everything we are. We spent all of history afraid that no one was out there. It never once occurred to us that something already had its hand on the door, and its dust already in our oceans. If this is the kind of question you want to keep chasing with me, take 1 second and subscribe. This channel exists to follow exactly these threads, the ones that start with a simple question and end somewhere that quietly changes how you see your own sky. Your subscription is genuinely what lets the next one get made, because there is one final piece, one last consequence of living inside a moving bubble on a wandering star, and it changes how you should look up tonight. Here is that final piece. Everything I have described is in motion. The sun is not anchored to anything. It is falling around the center of the Milky Way at about 230 kilometers per second, dragging all of us along with it. And as it goes, it carries our little bubble through one interstellar cloud and toward the next. It takes the sun roughly 230 million years to circle the galaxy a single time, one galactic year, and in just the time since the last lap, dinosaurs rose and ruled and vanished, and we appeared. Within a few thousand years, a blink against that enormous clock, the solar system will leave the cloud we are in now and cross into different gas, a different wind, a different sky. The view above us is not a fixed ceiling, it is weather. And it is changing, just slowly enough that no single human life ever notices. Which means the people who looked up 10,000 years ago were drifting through slightly different surroundings than we are. And the people 10,000 years from now will be somewhere else again, sailing through a patch of the galaxy we will never get to see. We are all just passing through on a star that is passing through inside a bubble that is passing through. Travelers who happen to look up during one particular stretch of a very long journey. And think about exactly when we are alive to see it. Not the generation that felt their way around the sun in the dark with Ulysses. Not the 1,000 generations before them who looked up and saw only flat points of light on a black dome. Us. We are the first humans who ever got to see the top of our own star. The first to hold the map of the bubble that holds us. The first to dig the ash of nearby supernovae out of the floor of the ocean. The first to measure the wind from between the stars as it breaks against our shore, and to watch it slowly change direction. After 4.5 billion years of facing the wrong way, we are the ones who finally turned around and looked up. And there is one last thing worth sitting with. The iron in that ocean dust. The iron in your own blood. The calcium in your bones. The oxygen in the breath you are taking right now. All of it was forged inside stars and scattered across space by explosions like the ones that blew our bubble. We are not just living inside the wreckage of dead stars. We are made of it. The cosmos above us and the body reading these words are the same material, briefly gathered together into something that can look up and understand where it is standing. That is the part I cannot get out of my head. For 4.5 billion years, the atoms that make you were scattered across the galaxy, blown out of dying stars, swept into a bubble, folded into a planet. They waited through every ice age and every extinction, and they arranged themselves into you, right now, at the one moment in all of cosmic history when a human being could finally look up and see the whole structure for what it is. We did not just happen to be here. We are the neighborhood's first real chance to understand itself. So tonight, when it gets dark, go outside and find the faint band of the Milky Way, if your sky is clear enough, or just look straight up. Remember that up is not empty, and that it never was. Remember that you are not standing still beneath a painted dome. You're riding on the deck of a moving ship, inside a bubble carved out by dead stars, through a wind you will never feel, toward a patch of sky that no one alive will ever reach. The emptiness you were taught to see up there is the one thing about it that was never actually true. The void above us was never empty. It was a face we had not yet learned to see, and it had been looking back the whole time. If you want to know where that ship is taking us next, what happens when the sun finally pushes out of this cloud and into the one waiting beyond it, I made a video on exactly that, and it will be right here waiting for you. I will see you there.